now in Chapter 6, Lesson 1, Powers and Exponents. Please join me on page 433. First, we need to talk about vocabulary. The product of like factors can be written in exponential form, where you have an exponent and a base. The base I always call big bottom base. That helps you remember that it's the bigger number on the bottom. We call that the base. Then the superscript, or Superman, is the exponent. And then these are factors. So I know when I have 10 to the second power, I'm going to write 10 2 times and multiply them together. So an example would be 5 to the 4th power, which means that I will have 5 times 5 times 5 times 5. So again, the big number on the bottom, big bottom base, the exponent is the superscript, or the Superman, superscript. That's how many times you are going to write the base down and then multiply. Factoring means the factors of a number. Alright, let's look at the real world problem. MP3 players come in different storage sizes, such as 2 gigabytes, 4 gigabytes, 16 gigabytes, where a gigabyte, or GB, means gigabyte. 1 gigabyte is equivalent to 10 times 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 10 bytes. So, if I were to write that, that would be big bottom base of 10, and my exponent would be 1, 2, 3, 4, 5, 6, 7, 8, 9. So, that's a huge number. And again, this is why a lot of times we'll use exponents, because the numbers are either too big or too small to represent as normal digits. Turn the page. So numbers expressed using exponents are called powers. For example, 100 is the power of 10 because it can be written as 10 squared, or 10 to the second power. So again, we have area. When we talk about area, we know, let's just say this is 10 units squared. Sorry, no, let's say this is 100 units squared, because 10 squared is 100. 100 units squared. That's where the 2 comes from. And then here we have 1,000. 1, 2, 3. 1,000 units cubed. And this is the volume. So when we talk about volume, it's always to the 3rd power. And when we talk about area, it's always squared or to the 2nd power. Some people ask me, well, what about the 4th power? The 4th power involves time. And so when you talk about objects in space and time, that would be to the 4th power. So, we also talk about cubes, perfect squares. Remember, I asked you to memorize the perfect squares. So let's just recap that. Perfect squares. That's your 1, 9, 16, 25, ... So that's 1 squared. Oh, we forgot 4, didn't we? Oh, we'll have to just slide him in there. 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, and on and on and on. Cubed is the same, except for now we have a 3. So 1 is 3 cubed. Why? Because 1 times 1 times 1 is 1. 2 cubed is 2 times 2, which is 4 times 2 is 8. 3 cubed is 2 times 2, which is 9, times 2 is 27, and we'll just stop there. Alright, let's look at the examples. So when it asks to write a number in exponential form, you're going to have a base and an exponent. In this case, we have 6 times 6 times 6 times 6. There are 4 of these guys. So that's 6 to the 4th power. We're now going to write 4 times 4 times 4 using an exponent. We know the factor 4 is the base. The factor is multiplied 3 times, therefore the exponent is a 3. And we would write that 4 to the third power, which can also be written as 4 cubed. The third power is cubed, so the third power we call cubed, and the second power we call squared. Everything else from that point on we just call power. So the fourth power, the fifth power, the sixth power. Now it's your turn. Okay, see you soon. Pause the video. These were easy. Did you get 7 to the 4th and 9 to the 7th? Again, big bottom base, little number exponent. Turn the page. So now, when it's asking you to write powers as products, product means to multiply when you talk about math terms. So what they're doing is saying, solve the problem or tell me what the actual number to an exponent is. So in this case, we have write 5 squared as a product of the same factor. So we know that's 5 times 5, and then we do the work. 5 times 5 is 25, so 5 squared is 25. Don't be alarmed. You can do powers of decimals also. So in this case, we have 1.5 cubed, or 1.5 to the third power. That means writing 1.5 times 1.5 times 1.5, which is 3.375. And hey, you can do the same thing with a fraction. So we're going to write 1/2 cubed, or 1/2 to the third power. That's the same as writing 1/3. Oh, sorry, I said 1/3, didn't I? 1/2 cubed, or 1/2 to the third power. That's writing 1/2 times 1/2 times 1/2. And then you do the math. 1 times 1 times 1 is 1. 2 times 2 is 8. So we know that 1/2 to the third power is 1/8. Now it's your turn. Pause the video. Did you get what I got? For C, I got 100,000. For D, I got 4.41. And for E, I got 1/16. Let's go back to C and talk about that for a minute. Powers of 10 are easy because all you have to do is say, if it's to the power of 10, you figure out what the exponent is, and that's how many zeros. So in this case, I know that I will have 5 zeros in my answer with a 1 in front of it. So those are easy to do. All right, keep going. So now in real life, again, we have a word problem. The zoo has an aquarium that holds around 7 to the power of 4 gallons of water. How many gallons of water does it hold? Now, I want to show you something that I do a lot. I know that 7 times 7 times 7 times 7. I can do 2 numbers at a time. That's 49, and this is 49. And then all I have to do is multiply those, and then I get 2,401. So again, I can do these in sets if I want to. Okay, so now it's your turn. Oh, look, it's a power of 10. You should be able to do this very quickly. By the time I finish reading this, you will have an answer, so there's no point in pausing the video. Michigan has more than 10 to the 4th. What did I say? Let's see. That's a 10. That's a 1 and 4 zeros. Okay. And it's lake, so we need to know how much that is. That's a 1 and 1, 2, 3, 4 zeros, which is 10,000 lakes. Wow. Boy, Michigan sure does have a lot of lakes, doesn't it? Okay, it's your turn. Please do the guided practice. Come back when you're done. Pause the video. Did you get what I got? In the first two, they just wanted you to write it in exponential form. So I got 8 to the 3rd and 1 to the 5th. Although you could do 1 to the 5th in your head. The answer to that problem is 1. Number 3, we have 1/7 times 1/7 times 1/7, which is 1 over 343. Number 4 is 32. 5 is 1.96. And 6 is 343 feet. So why do we use these? Again, it makes it large numbers manageable. The larger the number, the easier it is to write it in exponential form, or soon you'll learn scientific notation, again, where we'll use exponents to write numbers. Thanks for listening.